Hi everybody, this is Chapter 10 continued. We're going to look at 10.5 and 10.6 and the properties of circles in Chapter 10 and then 12.1, 2, and 3. In Section 10.5 we're going to look at arc measures, circumferences, and then arc lengths of circles. All right, we've talked about circles before, but only briefly. So just a reminder that a circle is the set of all points equidistant from a point that's called the center. When you name a circle, you always name it by the center point. So we name it by this point right here. So this would be, like if I were to name it, it would be considered circle P. And you would just put a little circle there to show that it is circle P. Just a reminder, the other parts to a circle, you have the diameter, which is the segment that goes from one side of a circle through the center to the other side, so it goes all the way across the circle. A radius goes from the center of the circle to one side, so it's half the diameter. Congruent circles have congruent radii, which makes sense. The radius would be the same if your circles were the same size. And a central angle is an angle whose vertex is the center of the circle. So a central angle would be something like angle BPC, which I'm going to shade in here, or they marked angle APC. This is a central angle as well, but the main thing is the vertex of a central angle is the center of the circle. Also on a circle you have arcs, and arcs are like the part of the circle. Think of it as kind of like the edge of the circle. One type of arc is a semicircle, so that would be half of a circle. Then you have what they call minor arcs, and those are arcs that are less than a semicircle. Think of a semicircle as 180 degrees, excuse me, because the circle is 360. So a minor arc would be less than 180 degrees. A major arc is an arc that's going to be greater than 180 degrees, greater than a semicircle. When we name minor arcs, you just name it by the two endpoints on the circle, so arc RS. When you name a major arc, to show that it's a major arc, you are going to use the two endpoints and at least another point within the arc. It could be multiple points. Sometimes you'll see arcs named with 5 points, but if it's a major arc, you have to use at least 3 points. All right, so here we're going to look at the circle and name the minor arcs, the semicircles, and the major arcs. Remember, minor arcs are less than 180 degrees. So if I look here, I can see right away that CE is a minor arc. It is less than 180 degrees. And then also arc AD. You put a little arc symbol above it. So we have AD, we have CE, and then AC right here, this arc right here, that's less than 180 degrees. So we could say arc AC, and then also we could do DE. So we have 4 minor arcs. Semicircles, remember, are half of the circle. So look for your diameters. So we have a diameter AE here. So a semicircle arc, and you're going to name that with 3 letters as well. We could do ACE. So this would be 1. Or we could do arc ADE. As another arc, so this one right here. Now, we can also, just erase a little bit. All right, we can also look at if we went from D to C, All right, so we got that line right there. We could go from D to C. And so we could say another semicircle would be DAC, or go below that, DEC. All right, major arcs, again, they have to be greater than 360 degrees. So if I'm looking for a major arc, I know that AE, this is a semicircle, so I could go AC to D. So I could say arc ACD or AED. You just have to put one of the middle points in there. I could go from C all the way over to A, so I could say arc CDA or CEA. Again, doesn't matter. Let's see, we could start at E and go all the way to C, so we could go all the way around here, so we could say arc EAC, and then we could start at D and go all the way to E, so we could say arc DAE. And again, the endpoints are on the ends of a major arc, but the point in the middle is just one point that's within the arc. And we will look at the measure of an arc to see not only the length, but how many degrees it is. And the measure of a minor arc is equal to the measure of its corresponding central angle. So whatever your central angle is, which is 50 degrees, that means that this arc, RT, is also going to be 50 degrees of our 360 degree circle. A major arc would be, whatever the minor arc. So if this minor arc here is 50 degrees, then if I were to look at this arc here, RQT, it would be 360 minus 50, or it would be 310 degrees. And then a semicircle is always going to be 180 degrees because it's half of 360. Adjacent arcs are arcs of the same circle that have exactly one point in common. So if I were to draw a circle, and I again apologize for my drawing skills, here's my circle, here's the center of my circle, here is an arc, and then here's another arc. So they have this point in common. And you can add the measures of the adjacent arcs together to get one large arc, which we just talked about previously. That's our arc addition postulate. We've talked about the ruler addition postulate, the angle addition postulate, the segment addition postulate. So same thing if you have two smaller arcs. So we have arc AB here. We have AB and BC. If you add them together, they will give you the measure of arc ABC, so the total measure of the two arcs together. All right, so here we're going to calculate the measures of the arcs in circle O. So we have circle O here. We want to find BC. So we know BC is right here, and the angle that it's connected to is 32 degrees. So that means the measure is the same. It's going to be 32 degrees. Now they want BD, which BD goes from B all the way to D. I know BC is 32, and I know CD is 58. So if I add those two together, if I add 58 and 32, that will give me 90 degrees. So arc BD is 90 degrees. Now they want arc ABC. So if we go, we went all the way over here. And if you look here, AC, that's going to be a diameter. So that means that ABC is going to be 180 degrees. Now, if you weren't sure, you could always, we know this is a diameter here. So, and we know this is 58, so we know this has to equal 180 and this has to equal 180. So you could do 180 minus 32, which we're actually going to do over on this side because next we need to find AD, which is right here. And again, I know CD is 58. This is a diameter of my circle, so that divides the circle into two equal 180 parts, 180 degrees. So now I'm going to take 180 and subtract 58, and we get 122 degrees for AD. So AD is 122 degrees. And remember, I used 180 here just because I knew this was a diameter and it divided it into 180 degrees. Sometimes with your circle, you're going to work with your 360 because a circle does measure 360 degrees. All right, next we're going to look at inscribed angles. And we're going to talk about them briefly here, and then we will also talk about them in section 12.2 as well. But an inscribed angle is an angle on a circle where the vertex is not the center of the circle, but it's on the side of the circle. So if I have a circle, again, pardon my drawing, here's the center of the circle, but my inscribed angle would go, the vertex would be a point on the circle, and the sides would be chords, so that angle would span the circle, wouldn't go from the center. To find the measure of an inscribed angle of a circle, it's going to be 1/2 the measure of its intercepted arc. So this angle intercepts this arc right here. So kind of think of it as if I extend it out, it's this arc. So if I name that arc, name these points A and B, the measure of this angle right here would be 1/2 the measure of arc AB. All right, next we're going to review circumference of a circle. And remember, the circumference is the distance around the circle. We use pi in our formula for circumference. And to get pi, the way that they found pi, we know it's 3.14 and it continues on without end, but we use 3.14 mainly. You take the circumference of a circle and divide it by its diameter, and you will always get pi. So if you measure the circumference of a circle, the distance around the outside, and divide it by its diameter, you will always get pi, or if your measurements are off a little bit, a number very close to pi. Coplanar circles are circles that are in the same plane, and coplanar circles that have the same center are called concentric circles. I kind of think of them as like a bullseye. So here's one circle with the center, and then if that uses the same center, here's my other circle. So those would be concentric circles. Just as a reminder and a review, we talked about the circumference of a circle. We can use two formulas. You could do pi times the diameter, or 2 times pi times the radius, because we know the radius is 1/2 of the diameter. We will use the circumference to help us find the arc length of an arc. Now, what we found before, we found the measure or the number of degrees that the arc took up on a circle, and all circles are 360 degrees. But the circumference, the distance around a circle, is not always the same. So when we're finding arc length, what we're finding is how long the length of the arc is, not how many degrees, but how long it is. That's what we're finding when we find arc length. And arc length is always going to be a fraction of the circle's circumference. And we will use fractions in here. We will use our circumference formula and the number of degrees. So to find arc length, what you do is you take the measure of the arc and divide it by 360, because there's 360 degrees in a circle, and then that will give you like what part of the circle it covers, 1/3, 1/6, whatever your fraction is, and then you multiply it times the circumference of a circle. So you can either do 2 times pi times radius, or pi times diameter to find the arc length. All right, so here we're going to find the arc length of arc XY, which is shown right here. So here's XY. Now, we need two things to do this. We need to know the degree of the arc, which we know that right here, this is a 90-degree angle. And remember, your arc degree measure is the same as the angle it intercepts. So because this is 90 degrees right here, arc xy equals 90 degrees. And we know the diameter of the circle is 16 inches. So when we find it, we are going to take our 90 degrees. We'll do 90 divided by 360. And then multiply it times our circumference of a circle formula. And we have the diameter, so I'll do 16 pi. Now, 90 over 360, we do know will simplify to 1/4. And then we're going to multiply that times 16 pi. Again, think of it as like 16 over 1. So we get 16 pi over 4. Or if we simplify, they want your answer in terms of pi, which means don't multiply it by pi, leave it in pi form. 4 goes into 16 4 times. So my answer, the length of this arc, is going to be 4 pi inches. Or if they had asked for the approximate answer, then you could multiply the 4 times either pi on your calculator, or I typically do 3.14. All right, so next we're going to find the length of arc, in this case, XPY, because that's in red. And they want your answer again in terms of pi. So the measure of this arc, they gave it to us, is 240. So we would have 240 over 360. And then they gave us a radius this time. It's 15 centimeters. So we'll do 2 times pi times 15. Now, I can do a little simplifying before I multiply this out. I can simplify this fraction. First, I'm going to divide by 10. So I'm going to get rid of those zeros. So now I have 24 over 36. And I'm going to do 2 times 15 and get 30 pi here. Now, I do know that I can divide both 24 and 36 by 12. And if I divide them by 12, it becomes 2/3 times 30 pi. And if I simplify that fraction, it makes life a little bit easier to get started. Then I can do 2 times 30, which gives me 60 pi. 3 times 1 is 3. If I divide 60 by 3, I end up with 20 pi centimeters for my arc length. All right, and the last thing we're going to mention are congruent arcs, are arcs that have the same measure and are in the same circle or in congruent circles. So think congruent means exactly the same. They're going to have the same measure, and they are in the same circle, or they have to be congruent circles, so they have the same arc length as well.